Hello and welcome to Lesson 1 Digital Circuits, an introduction to number systems from the Digital Fundamentals series. In this lesson you will learn about binary, octal, and hexadecimal number conversions. Okay, here are your objectives. Introduction to number systems and counting, decimal and binary conversions, binary and octal conversions, and binary and hexadecimal conversions. Number systems and counting. This is Module 1. In this module, you will learn counting in decimal and binary, counting in octal and hexadecimal. Remember when you was in grade school and they taught you how to count? Well, in each system, it's kind of similar. So you started off with decimal, 0 to 9. Since there's 10 digits in the decimal system, then you started over with 1 0 and went to 1 9, then you started over with 2 0 and so on and so forth. Well, in the binary system, you only have 2 digits. That's a 0 and a 1. Then it starts back over and have the 1 0, 1 1, and then you go to the next place. You put your 1 there and you put your zeros there. Okay, so in the octal system, it has 8 digits, 0 through 7, and then it starts over. After 7, it's 1 0, 1 1, so on and so forth. In the hexadecimal system, it has 16 digits, 0 through F. Okay, once you get to F, it starts over with 1 0, so on and so forth. Okay, now here's 2 methods of how to convert from binary to decimal and decimal to binary. Okay, how to convert the number in binary to decimal. Okay, so when you have this number in binary, then the binary system is based off of multiples of 2. So you would have weights for each position. So this first position right here would be 2 to the third, that's 8. The second position would be 2 to the second, that's 4. 2 to the first, that's 2. 2 to the 0, that's 1. So whatever numbers you got in that position, you're going to multiply it times the weight to give you that number. Okay, so that's how I got 6. Now I left the rest of these as an exercise for you to do. Okay, so this one right here, converting from decimal to binary, then you're going to put your weights up here, 16, 8, 4, 2, and 1. The reason why I did 16 is because the biggest number that four-digit binary number can make is 15. So 15 is less than 29, so that's why I did 16. So what you're going to do is you're just going to divide these numbers in there. So you have 16 goes into 29 one time with 13 left over. Then you have 8 goes into 13 one time with 5 left over. 4 goes into 5 one time with 1 left over. 2 goes into 1 0 times with 1 left over. And 1 goes into 1 one time with nothing left over. Okay, so I left this up as an exercise for you guys to do. And just remember, if you remember those first 15 numbers, no matter what system it is, you remember that first chart, then you can do these right here without even having to do it like this. 15, 14, 7, and 9, and 10. The other ones you have to do to this method what we just discussed. Okay. Now, here's an alternate method for decimal to binary conversion, and it's called repeated division by 2. Okay, so you're going to take that decimal number, then you're going to divide it by 2. When you have a remainder, then you put a 1 right here. When you don't have a remainder, you put a 0. And you keep this going until you get all the way down where you can't divide no more. Okay. Then you have your most significant bit and your least significant bit. So this would be the leftmost bit. Okay, so it'll be 1 1 0 0 1 0 1 for your answer. Now, you're going to have to practice this right here so you can get familiar with it. Okay, so let's keep going. Okay, here we have binary and octal conversions, and this is module 2. Okay, in this module, you're going to learn about binary to octal conversions and octal to binary conversions. Okay, so I copied this chart from up above so you can see which numbers is which. Okay, so what you want to do when you have binary to octal, you want to break these up into groups of 3. Since when you get to 7, if you count in octal, 1 1 1 is 7. Then they're going to start back up with 1 0 0 0. Okay, so break the binary bits up into groups of 3. Then you just take that group of 3 and you just find the equivalent number, the decimal number, and then you just put it in here and then that'll be your octal number. Okay, so 0, 0, 0, we know that's a 0. 1, 0, 0, we know that's a 4. So that's how I got 0, 4. Now, these spaces are just for clarity. So you wouldn't write the space in there for your final answer. Okay, so if we're going to do this one, we'll break it up. Okay, so it'll be 0, 0, 1, 1, 0, 0. So let's find, okay, so 0, 0, 1 is 1. 1, 0, 0 is 4. See? So we just put that up there. So I left the rest of these as an exercise for you guys to do. When you convert from octal to binary, you're just going to do the reverse. Take that octal number and then for each digit, split it up into the binary, to its binary counterpart. Okay, so let's do 57. So 5 is what? 101. So that's why I got that 101. And I put this in there just for clarity. Okay, 7 is what? 111. See? So there you have it. So if you was doing 63, you find 6, 110, you find 3, 0, 1, 1. And again, the space is in there just for clarity. Okay. Welcome to Module 3. In this module, you're going to learn about binary to hexadecimal conversions and hexadecimal to binary conversions. Binary to hexadecimal and hexadecimal to binary conversions. Okay, so with the hexadecimal and binary system, you want to break these bits up into 4s, since the hexadecimal system is 4 binary bits for each one of the numbers in hexadecimal. So break these up when you get, and if you don't have enough to make 2 groups, you always can put some zeros out front. That won't change the value of the number. So what we did here, we broke this up. Then we found the different corresponding 4-bit patterns, and we found out what that hexadecimal number was that corresponds to it. Okay, so 0, 1, 0, 0, that's a 4. 0, 1, 0, 0, that's a 4. Okay, we did something similar to this one. 0, 0, 1, 0. We go right here. 0, 0, 1, 0. That's a 2. 1, 1, 0, 0. That's C. 1, 1, 0, 0. Okay, so these right here, they not that difficult. Okay, so then you have the hexadecimal to binary conversions. You're going to do something similar like you just did in the other module. Okay, what you're going to do is you take each bit or each number right here, and then you just write the 4-bit pattern of the binary to make it. Okay, so let's do 6A. Okay, so 6 would be 0, 1, 1, 0. Remember, I just said just put that in there just for clarity. Okay, and then A would be 10, 1, 0, 1, 0. See? So that's what you have. 0, 1, 1, 0, 1, 0, 1, 0. So you just need to practice and just remember, if you can remember from 0 to 15, then you won't have that much trouble with this conversions. Okay, here it's time for practice. Take this right here, it's going to be done for an assignment. Take this and then fill these blanks in. And what you're doing, I'm teaching you how to count from 100 to 110 in the binary, the octal, and the hexadecimal systems. Okay, and then I put your weights up here already. Okay, so you remember about the weights, these are just the powers of each of the numbers in the system. And then you multiply these numbers times their position. Okay. Now, we want to thank you for taking this time to allow us to provide you with the number system conversions. And we hope that you've learned something in this lesson. If you have any questions, you can reach out to me and I will be sure to help you. Okay, thank you and have a nice day.